these two presentations, you understand there is a need for research to support humans in space. And so far, we haven't been able to accomplish this goal. Space is a hostile environment, so we need research for that. To do research, we cannot do with just 600 astronauts in total, and some go one time, some go two times. So there's not enough people to. No, it's not okay. Εντάξει, θα το κάνουμε. So that's why we have the simulated, the analog environment, so we can do more research for several reasons. And among them is that we have much more people that we can test in several environments. We're here. Okay, we're done. So we have two kinds of analog environments. We have the field analogs and we have the simulations. So the field is real environments, danger, isolation, confinement. The simulation, it's constructed environments. So it's head-down tilt bed rest, we will see about that in a moment. And why we use these ground-based analogs, I just explained. Not all experiments can be done in flight. There is limited life of the International Space Station. The resources are limited, and they take longer to complete their studies, and ISS may not be the best platform for the study. It allows the selection of best candidates, so before you send astronauts, cosmonauts to space, you know their abilities, because you already tested them. Saves time, money, and what you do with the spaceflight analogs, you just create a situation that produces effects on the human body, similar, not exactly the same, to those experienced in spaceflight, physiological and behavioral and cognitive. So we have human subjects like the returning astronauts, we have the bed rest facilities, and we have the submersion. That's the best simulated environments to do research. From the animal point, we have the telesuspension of the rodents, handling suspension. We have the tilt bed rest, as you see, and we managed to have an international standardization procedure, so everybody follows the same standards, and then we can compare among all scientists, we compare our data. And that's a very good support to the space science community. So we have the guidelines for the conditions, the standard conditions that you can use if you do better studies, and we have the standard measures. So there are many facilities. One that we have used for our experiments with Professor Bamidis is the ENVI hub. It's the German and DLR based. It's a big and very new, since 2016 field. So what we did, just very briefly, we did research on artificial gravity and metabolic disorders and how this can prevent the metabolic disorders induced by inactivity or bed rest. So we have here the subjects. We studied the hormonal sleep disturbances, arterial stiffness, muscle atrophy, and we have, actually we planned for a human centrifuge, but because it was not possible, so we did the sledge, which is another type of countermeasure. This is our team, Professor Bamidis, and especially Christos Frantsidis, if he went there, and Polixeni, and they helped a lot to collect all the data. So from there, from 2017 to 2021, we had 10 papers published on this data. So we have those recently. Then we come to the submersion. This is used to simulate microgravity by the Russians Now the Chinese also got some submersion devices. This is also a good simulation of bed rest and inactivity. And then we can use the animals like a hand limb suspension or the unloading. Unloading is milder. Hand limb suspension is very specific. So we did experiments at Aristotle University in 2004 with the hand limb suspension, and we already have a paper on the electrophysiological and hormonal adaptation of rats in decreased gravity. So that was one of our papers on that. Then you can simulate by parabolic flights. The problem with parabolic flights, it's very short, and you have to do 30, 40 parabolas. The airplane goes up and then goes down, and you feel this free fall, but it's only 24 seconds. So research, it's only limited what you can do in this limited time. So in the field of simulations, we also did the field simulation many, many years ago, and we did it in collaboration with the Geophysical Institute of US. And this is, it's called Kameni. It's a place in Santorini. We did our research on iron bacteria. And these iron bacteria, they can live in low oxygen and high iron. And this is approximately the environment of planet Mars. So this is the students that helped us to do the experiment, and we had also a publication on this issue. Another very interesting simulation is the Antarctic stations. They have for decades been used as research analogs of spacecraft, especially space stations such as Skylab Mir and the International Space Station. And those two environments, what they share is actually isolation, confinement, discomfort, danger, and remoteness. And we have here an excellent scientist, colleague, and member of our association, Dr. Kaimakamis, who is going to present you his experience on that. So, in the field of countermeasures, I will be very brief. We developed the Greek short-arm human centrifuge, and we applied space technology on patients. So far, we used whatever we knew from Earth to apply to space, but now I thought that it's good to use the space technology to help people on Earth. So what we did is that, and we succeeded. The team was very successful. We will see if we can just take a look, a very quick look, if it's possible. If not, it's okay. Δεν το κάνω εγώ. Δεν το κάνω.
Οδυσσέα 05. Οδυσσέα 05. Για ένα λεπτό. Ναι.
Όχι, πάνε, ανέβαζε.
Δεν θέλετε ένα λεπτό.
I will go there. We had already 2 publications, and the third is coming up now. And I will just an example of a lady. She was paralyzed, left side paralyzed. She could not feel her left hand, her left foot. And here is some videos. I will not play them. I will play the last one. So the second week of rehabilitation with the centrifuge, the lady started crying. I thought, what happened? I mean, and she said, I'm feeling my head. And then the next moment, next week, she was feeling her foot. And she said, I never felt that for 15 years. And then we started all that, and then 3 months. Space medical research is very important to maintain good quality of life for the astronauts in space, but also improve the quality of life on Earth. And there are many devices that have been produced, developed to help astronauts, and then we use them to help us on Earth, like the automatic insulin pump, the pacemaker, the automated urine analysis and all that. I will not go into details. So in the field of other countermeasures, I will just mention very briefly, because it's a Russian proposal. We have the suit stimuli, which is electrical stimulator. We have the compensator of support unloading. It's 2 modes of mechanic stimulation on the feet. It's like you are walking. And depending on which stimulation you do, you might have from 75 steps a minute to 120 steps a minute. Then the Corvid, foot loading, imitating gait movement. This is very good for stroke, cerebral palsy, Parkinson, and all that. And the very good suit, the original suit. This is also very good. People who cannot walk, I mean, they wear the suit. They're paralyzed, they wear this suit and they walk. This is incredible, all these devices. So space exploration imposes new challenges on human system and terrestrial life in general. So far we know, and we can go up to short missions to the moon. That's it from our technology. But we need to create autonomy, more autonomy if we want to stay longer on the moon, and all the rest, communication, it's there. Most of the medical risk is the knowledge is there. There are some things that we might work with that, but for missions to Mars, we need to do a lot of work because there is a lot of medical risk we don't know yet. The communications are impossible and probably no access to Earth facilities. Autonomous medical care, it's absolutely required, and there is a lot of research groups that are working on that. Thank you.
Thank you very much, Chrysoula. So now we proceed to Dr. Vangelis Kaimakamis.